Let's have another problem in our application of Newton's laws. Find the average retarding force when a 5-gram bullet traveling at 500 meters per second penetrates a block of wood a distance of 5 centimeters before it stops. Maybe it is good to start illustrating the problem first before any mathematical equations. So this is our bullet just before hitting the block of wood. And then the initial velocity is the 500 meters per second. And then it penetrates to a distance x before it stops. So this is our final velocity, which is equal to 0. Given in the problem is the mass of the bullet equal to 5 gram, or this is equivalent to 0.005 kilogram. The initial velocity just before it hits the block, 500 meters per second. And then since it stops after covering a distance x, so the final velocity is 0, and the distance it traveled before the bullet stops is 0.05 meter or 5 centimeter. So the problem is to find the retarding force. The retarding force is the force which causes the bullet to change its state of motion. Therefore, it is equal to ma. We can solve the problem if we have the acceleration, since we already have the mass of the bullet. But then we do not have the acceleration yet. But we can solve the acceleration using the kinematic equations, since we have the given parameters. So for the solution, let's start solving the acceleration. From these kinematic equations, that the square of the final velocity is equal to the initial velocity square plus the twice the acceleration times the distance it travels. And so solving for acceleration, this is just equal to, since this is 0, our final velocity is 0, so the 2ax is just equal to the negative or v naught square. Or finding a is just equal to the negative v naught square over 2x. And then plugging in the values, you will have this magnitude of acceleration. And what have you noticed? The acceleration is negative. Therefore, this is also the direction of the force. Since we already have the acceleration, we can plug in the value of A to our equation. So plugging in, since mass is given, and then we have the acceleration magnitude. This is now our answer. This is the net force that retard the motion of the bullet.